Welcome. Thank you for coming. My name is Rose Hartman, and I use she, her pronouns. I am a data science educator with the Arcus project in DBHI. Today's talk is the first in a series of talks about SQL that we'll be offering over the next several months. And we are recording today, so please leave your cameras off and your mics off until the question time at the end. If you do have any questions that come up during the talk, feel free to put those in the chat. Okay, go ahead and get started here. So today's talk is called Demystifying SQL. And after this session, we will expect that you'll be able to define the acronym SQL, explain the basic organization of data in relational databases, explain what relational means in the phrase relational database, and give an example of the kinds of tasks SQL is ideal for. So today is about providing a high-level overview of SQL. Excuse me, what it is, what it's good for, and why you might want to learn it. We won't be doing any hands-on coding with SQL today, although we will during some of the future sessions in this series. And before I jump in, I want to be sure to acknowledge the material for this talk is based really closely on the Dart module, Demystifying SQL, written by Peter Camacho and Joy Payton. So many thanks to Peter and Joy for their work developing this excellent content. And of course, any errors or awkwardness in this version are mine, not theirs. We are firm believers that the best way to learn is to practice. So although we won't have any hands-on coding practice today, we will have short sort of quizzes that come up to help you check your understanding and consolidate learning. So those will be slides that say your turn, and I'll put a poll in Teams for you to respond to when that comes up. So go ahead and put your answers in there. It will be anonymous. Your name won't be associated with your response. And then afterwards, we'll discuss the answer together. Okay, so let's dive in. What is SQL? So SQL, or SQL, stands for Structured Query Language. And you can pronounce it as SQL, or you can just say the letters SQL. People do it both ways. SQL is a programming language that's used to interact with relational databases. So what is a relational database? Oops, excuse me, sorry. What is a relational database? Let's start with the word database. A database is a data storage solution that stores data in objects called tables. Tables are objects comprised of columns, also sometimes called fields, and rows, similar to data in an Excel spreadsheet or a CSV file that you might be used to working with. When we add the word relational as a modifier, we mean that the tables within the database are related to one another by columns that they have in common, like a patient ID column that appears across several different tables. Usually with a relational database, you'll use several different tables to answer a single question, and you use information from one table to look up information in the next, like a series of clues. So let's dig into this idea a little bit further by looking at an example. So here's a very small, made-up relational database. This is a relational database with just 3 tables: demographics, encounters, and medication order. Each of the tables are rectangular or tabular in shape, and they organize data in rows and columns. So just glancing quickly at these 3 tables here, can you see the column that they all have in common? So if we look at, for example, the demographics table, you can see we have patient ID, date of birth, sex, last name, and first name. And then in the encounters table, patient ID, encounter ID, encounter date, and then ED indicator. And the medication order table has patient ID, provider ID, med ID, and order date. So it's that patient ID column that's showing up the same across all 3 of these tables in this little relational database. So using these 3 tables, how would you figure out how many times Prairie Dawn, which is one of our made-up patients here, had an encounter in the emergency department, which would be an ED indicator equal to 1? So let's walk through that example together. First, we discover the patient, Prairie Dawn, in our demographics table. And we note that this patient has a patient ID of SMLE 321. we can then use this patient ID to find related data in other tables. For example, when we look in the encounters table or the medication order table, we won't ever see the patient name Prairie Dawn, but we do find her ID, SMLE 321. So looking at the encounters table here, I can follow that patient ID number for Prairie Dawn, and I can see the first encounter is one of her encounters, and it has ED end equal to 1. The second encounter is another one of Prairie Dawn's, and it has ED end equal to 0, so it's not an emergency department encounter. Then we have some encounters from a different patient, and then a third encounter for Prairie Dawn again with ED end equal to 1. So by following that patient ID through the encounters table, we can determine that there are 2 encounters for Prairie Dawn with ED end equal to 1. So relational databases work by using data fields like IDs to allow us to find out data about a patient or an encounter or a purchase order or another thing that we're interested in by following the matching ID into other related tables. The primary benefit of the relational database model is the ability to use columns containing the same data, things like patient IDs, to create complex reports combining information from multiple tables. This enables users of the data to derive specific information from the data in highly customizable ways. So now that you have that background, you can think of SQL as the computer code or the language in structured query language that you can use to ask explicit questions called queries about the information in your relational database. So zooming out for a little bit of background, SQL was created in the early 1970s by IBM as a method for more easily accessing information from their internal database system. By 1979, Relational Software Inc., which is now Oracle Corporation, released the first commercially available implementation of SQL as part of their Oracle V2 database application. And today, SQL is the most common programming language for extracting and organizing data in relational database systems. So SQL is not only very commonly used, it's also very well established. SQL has been around much longer than other programming languages that you may have worked with. Okay, so here's our first interactive slide here. You can check your understanding. I'm going to activate this poll for you here in Teams. So go ahead and I'll give you a moment to look at that and respond. I can see people are paying attention, doing a great job here. Some of the responses are coming in, and it looks like almost everybody is getting this correct. SQL stands for, structured query language. All right, so let's do one a little bit trickier now. We've got a second interactive poll here, and I'd like you to read through these and click which of them correctly describe relational databases, and there may be more than one correct answer here. All right, wonderful. It looks like most of the responses have come in. So for this one, the correct answer here would be B, D, and E. So relational databases are a data storage solution, and they store data in tables, which are in turn organized into rows and columns. Relational databases use SQL as a way to access data, search for data meeting particular conditions, and connect related data using columns that the tables have in common. This allows for extracting data in very specific and customized ways. So great job. Thank you all for humoring me there. All right. All right, so let's talk a little bit about when to use SQL. SQL should be used anytime that you need to access data stored within a relational database and select data that meets your requirements. Usually, SQL is used for getting custom data sets for export and downstream analysis. For example, you might use SQL to export data for doing statistical analysis and visualization in other languages, like R, Python, or Stata. If your source data comes from a relational database, like a data warehouse, for example, your major data transformations, like selecting just the columns that you care about or selecting only certain rows, should be done using SQL. This ensures that the data set that you export from the relational database is pretty close to the final data that you will analyze or visualize. And this is because, especially for large data sets, SQL is a much more efficient tool for large-scale data transformations than your traditional scripting or analytic packages. So you should use SQL to get close to the final data that you want to analyze and then export it. If you think about carving a sculpture out of stone or wood, you can imagine that the rough work of getting rid of big slabs of material that aren't needed can be done with powerful instruments like chainsaws or jackhammers. And then when an artist gets close to the shape of the final product, they might switch to smaller tools to give the sculpture its final form. In this analogy, SQL is the heavy-duty tool that gets your data close to its final form. It's a very good idea to document your SQL queries and save them, because this allows you to show your steps and give data provenance. This helps with reproducibility and standardization of your work. And it might also help provide a place for you to start for future projects, saving you a little bit of time down the line. So when should you not use SQL? Although SQL is a great tool for organizing your data into meaningful data sets for extraction, it's usually not a great tool to use for your actual analysis work. Despite having many functions for simple text parsing, SQL is not the tool or the language that you would want to use for advanced NLP, natural language processing work. Similarly, SQL does have some basic statistical functions, but it isn't intended to provide statistical analysis at the level of a statistical programming language like R. And SQL also doesn't have any capabilities to directly support data visualization work. For all of these downstream analytics use cases, you'll want to use an actual analytical programming language or tool, like R or Python. So you don't use SQL for your actual analysis work. You would switch to a tool like R, Python, or Stata for that. Although all SQL implementations have a similar structure and the same basic syntax, each different SQL database product often has its own minor variations in dialect. Colloquially, people refer to the different SQL dialects as different flavors of SQL. So some popular flavors of SQL are MySQL or MySQL, SQLite, PostgreSQL, Oracle, and BigQuery. A given database will be set up for one particular flavor of SQL, so you generally don't get to choose what SQL implementation to work in unless you happen to be the one designing the database. Instead, you'll use whatever the SQL flavor is for the database you want to access. The most common difference between different SQL flavors are the availability of different functions that users can use for data manipulation, as well as the types of error messages that will be returned to the user when running code with syntax problems. That said, knowing the specific flavor of your SQL database is especially helpful when first getting started writing queries and troubleshooting errors. When you're trying to troubleshoot a SQL query, being able to add the name of the implementation to your search terms will help you to get more relevant results. So a SQL query is essentially a question or a request for data written in a very specific structure. So let's take a closer look at how to compose a SQL query. But first, a word of encouragement. If you are one of the many people who feel anxious when they see code, you have a great opportunity today. We're going to give some simple examples of SQL code to help you build your intuition about SQL, but you won't have to write or run any code. And we're only going to barely scratch the surface of SQL syntax, the supported commands and how you write them, the grammar and vocabulary of SQL. The goal today is to help you build your intuition about what SQL is good at, which is picking out just the right data. So this is like a no pressure situation. With that frame in mind, let's take a look at what SQL queries actually look like. At a high level, we generally provide 3 pieces of information when constructing SQL queries. 1, the name of the table or tables where the data is stored. 2, the column name or names that you want to look at from the tables you specified. And 3, any filtering conditions that you want to apply. You put these 3 basic pieces of information together using the syntax shown below to create a SQL query. So select 2, the column names, from 1, the table, where 3, any filtering conditions. For example, here are some sample queries, each of which take place on just a single table. Select column price from table's product, where product type equals fruit. Or select med ID and order date from table medication order. Or select star from table patients where age is less than 20. And we'll come back to that star trick in a moment. So a select statement is used to specify which columns you'd like to have returned as output from your SQL query. The basic components of a select statement are the select and from keywords. The from keyword is used to specify the table or tables that hold the data you're interested in, and the select keyword is used to provide a list of columns within those tables that you would like returned as output. I also want to note quickly that many people choose to write SQL keywords like from and select in all capital letters, like we're doing here, but that's just so that they stand out clearly in your SQL code. It's not actually a language requirement. So your SQL queries will work just as well if you stick to lowercase. This is just a style recommendation to use all caps to help those words stick out, make it a little bit easier for humans to read. So if you would like to return all of the columns from the table or tables specified in your SQL query, you can use the asterisk wildcard character, as shown in the example here. You'll notice that we did put a line break between the asterisk and the from keyword. So we started that the second piece on a new line. Spaces and line breaks, or white space, don't actually matter for SQL. This is just like capitalizing or not capitalizing the keywords. You can run your code all in a single line, or preferably you can add indentation and spaces that will help make it, it'll help make it easier for human readers to understand your code. So if you'd like to select only a specific set of columns in your select statement, then you'll need to explicitly list out each of those columns after the select keyword, with each column name separated by a comma, like select last name, comma, first name, comma, date of birth, comma, sex from patient. The where clause, using the where keyword, is a section of your query used to specify any filtering logic that should be applied to your query before returning any output. It's optional, but very useful. So you use the select to specify the columns that you want and where to specify the rows that you want. Let's look at an example. This example uses the where clause to filter output on only those records that represent female patients. So select star to get all the columns from table patient where sex equals F. This will return everything in the patient table for just the rows where sex equals F. And although the previous example lists only one constraint for the data set, the where clause can contain any number of filtering arguments needed. So here is a slightly more complex example. Select star from patient where sex equals F and date of birth is greater than or equal to 2019-0101. So this would return all of the columns from the patient table where the sex is female and date of birth is greater than or equal to 2019-101. All right, we have another interactive poll here. So which of the following correctly describe the strengths of SQL? Take a moment to read through those and click all of the ones that you think apply. So great, I see lots of responses coming in there, and it looks like almost everybody is selecting the correct ones here. So it should be A, C, and E. SQL is great at working with rectangular data, so that's data stored in tables with rows and columns. And if the data you want to use are stored in a relational database, then you'll likely need to use SQL to access the data you need. Its powerful select, from, and where syntax makes SQL an ideal tool for isolating just the data that you care about, whether that's specifying the columns that you're interested in or limiting your data to just those rows that meet certain conditions. However, SQL is not great for fine-tuned statistical, linguistic, or data visualization purposes, so you'll want to switch to another tool for those tasks. Okay. So to recap, because we've covered actually kind of a lot of content here, we learned about the language SQL or SQL, which is an acronym for Structured Query Language. It's a powerful tool for requesting specific subsets of data from a relational database, and it's been around since the 1970s because of its efficiency and utility. We also introduced you to two important elements from the language: the select statement, which uses select and from, and the where statement, which uses where. We also discussed what SQL doesn't provide, like robust language and statistical processing and data visualization. SQL is a tool that ordinarily is used in concert with other tools, each one used in its area of greater strength. And finally, you learned about the structure of relational databases, data stored in tables, which are comprised of rows and columns. And columns may contain identifiers that allow data from different tables to be related to one another. And that's why the word relational appears. So I have a couple links here for some additional resources that we really like as other sort of introductions to SQL and relational databases. I'll have someone pop those in the chat there. Elizabeth might already be on that. And these links are also available on the slides, which we circulated at the beginning. Thank you, Elizabeth. And we'll put a link for those in again as well. I also do want to highlight, this is just the first talk in a series of talks about databases in SQL that we're going to be doing over the next several months. So this same talk will occur again on the 28th. And then in December, we have a new one, that database normalization. And then in January, February, and March, we're really going to get into actually working with SQL, practicing queries, and using them to work with actual relational databases.